In this lecture, we will explore the concept of Git repositories. By the end of this lecture, you will learn the structure of a Git repository, the role of the staging area, and the various states of files managed by Git. Let's get started. A Git repository is composed of three main areas: the working directory, the staging area, and the object database. The process of storing data in Git involves modifying files in the working directory, adding the changes to the staging area, and then committing these changes to the object database as a commit object. We will dive into each of these areas in detail in a minute. In Git, the repository is a hidden directory named .git. This directory contains all the data Git uses. Previously, we are looking at the repository's abstract structures. Let's take a closer look inside this directory. The folder outside of the Git directory is the working directory. Currently, the working directory contains 7 HTML files, such as channels.html and commands.html, as seen in the screenshot. The staging area is represented by a file called index. We referred to the staging area as the index earlier because in Git, the staging area is actually implemented as a file named index. Lastly, within the .git directory, there's a folder called objects where Git stores objects like commits. You don't need to know all the details about every file or directory inside the .git directory. For now, it's enough to understand that the staging area and the data stored by Git are all contained within the .git directory. Let's take a closer look at each area of a Git repository. First, the working directory. The working directory is where the project files managed by Git are located. This is where users add or modify files. When you check out a specific commit in Git, the content of that commit is reflected in the working directory. The staging area is where the content to be committed next is held. The existence of staging area is one of the significant differences between Git repositories and traditional version control systems. Without a staging area, every change would have to be committed all at once in a single commit. With the staging area, you can selectively record changes flexibly. The smallest unit that can be added to the index is a single line of a file. As we discussed earlier, the staging area is actually implemented as a file named index in the .git directory. Lastly, there is the object database. The object database is located in the objects directory inside the .git directory. When the commit command is executed, the content in the index is turned into a commit object. The 4 types of objects used by Git to store data, commit, tree, blob, and tag, are stored here. We will cover the objects used in Git in more detail in another lecture. So far, we've looked at the structure of a Git repository. Now, let's learn how Git manages files. Git manages files within the working directory, but it doesn't manage all of them. Files that Git manages are in the tracked state, while files it doesn't manage are in the untracked state. Tracked files can be in either the unmodified or modified state, depending on whether they've been changed. Modified files can be added to the index. Once added to the index, the files in the staged states. When you commit, the content in the index is turned into a commit. To summarize, files tracked by Git can be modified, and modified files added to the index can be committed. There's no need to memorize these states. As you use Git, you'll become familiar with them naturally. Let's look at the diagram to understand how file state changes occur in Git. Shall we go through it step by step from the top? To convert an untracked file to a tracked file, add the file to the index. An already tracked file changes from the unmodified state to the modified state when it is edited. Modified files can be added to the index. When added to the index, the file state changes to the state and the file can be committed. Committing the changes to record them, changing the file state back to unmodified. To stop tracking a file, you remove it from the tracked files. Based on the Git repository structure and file state management knowledge we've covered, let's explore how the index and the object database change as the file state changes in Git through an example. There's no need to memorize this part either. Just understand it as this is how data storage in Git happens step by step. The left side of the diagram represents the repository structure, and the right side shows the state of the index and the object database. Currently, the working directory contains the file name hello.txt with the content hello world. This file is not yet tracked by Git. The detailed state of the index can be seen in the diagram. Since there are no files being tracked by Git at the moment, the index is empty. Add the hello file created in the working directory to the index. In the left diagram, you can see that the hello file from the working directory has been added to the index. At this point, looking at the index in the right diagram, you can see that a blob containing the content of the hello file has been created, and the index is pointing to this blob. The blob's hash is B45EF6F, and the index points to the same hash. A blob is an object used by Git to store the content of a file. This result shows that a blob is created at the point when changes are added to the index before they are committed. This diagram shows the state of the index and the object database after the hello file in the index has been committed to the object database. When a commit is performed, as shown in the blue area of the right diagram, a tree object is created from the index, and a commit that points to this tree is generated. The commit contains the information tree 79321ED, indicating that the commit is pointing to the tree. At this point, the content of the hello file is fully recorded in the object database, so the hello file is in an unmodified state with nothing more to record. Now, let's add the sentence hello Git to the hello file. The hello file has been modified, but as shown in the right diagram, the state of the index and the object database remains the same as before. The current changes exist only in the working directory and have not been reflected in the index, so the state of the index and the object database has not changed. When the modified hello file is added to the index, a new blob containing the updated file content is created as shown in the right diagram. The index now points to this newly created blob. You can see the blob with the hash A4A257A. This is the newly created blob. The previously committed content remains unchanged in the object database. This is the state after committing the modified hello file to the object database. A new tree with the hash 2B797A6, represented by the middle blue area, is created, pointing to the blob generated through the index. Additionally, a new commit with the hash 6940674 is created, pointing to this tree. The green commit at the top is the newly created commit. This commit has the previous commit as its parent. If you look at the top green commit, you will see that the parent is A2C4C2B, which is the hash of the previously created commit. Every time Git record changes, it creates objects called blobs, trees, and commits. Let's represent each object with shapes, squares, triangles, and circles. Each time Git adds new changes, it creates a commit graph like this. What we primarily see when using Git is the commit history made up of these commits. Typically, we rarely need to directly look at the trees and blobs except for commits. Let's take a closer look at Git's commit history. Git's commit history, implemented as a directed acyclic graph, or DAG for short. In data structures, a graph consists of nodes and edges. This diagram represents a graph. The round parts are nodes, and the nodes are connected by lines called edges. This graph is a graph with nodes and edges, but no direction. This graph has directions, but it's a cyclic graph. Here, cyclic means there is an edge that starts from one node, goes through other nodes, and returns to the starting nodes. In the top node, you can see a path that loops back to the starting node in a counterclockwise direction. This graph is a directed acyclic graph, DAG, meaning it has direction and does not contain cycles. In Git, each commit contains information about its parent's commits. This information provides directionally to the commits. When you look at the commit history in Git logs or Git apps, it is often represented as shown in this diagram. However, a more accurate representation of the Git commit history would include arrows to indicate directionality like this. As we have seen, each Git commit points to the previous commit or parent commit. Git uses a DAG structure in a horizontal direction per commit. Below the commit, there are trees represented by blue triangles and blobs represented by red squares. The commit also points to these trees and blobs using a DAG structure. Therefore, we can say that Git uses a DAG data structure globally to store data. Let's practice creating a repository in the terminal and making commits using the repository. First, we create a directory where the repository will be initialized. Let's make a directory named repository test and move into it. If we check the directory's content, we will see it is currently empty. By running the git init command, we can create a new Git repository. Using the ls command, we can confirm that a .git directory has been created. Let's navigate into the Git directory. Here, using the ls command, we can see the directory structure we discussed in the previous lecture. Let's go back to the previous directory. Currently, we are in the repository directory that we created. Let's clear the terminal. Using the git status command, we can check the current state of the repository. The repository is on the main branch, and there are no commits yet. Additionally, there's nothing to commit. Let's add two files to this directory. While we can copy files from the terminal, it's easier to use Finder for this demonstration. We will see that the directory we created repository is empty. We copy two files into this directory. Let's return to the terminal and check the file list in this directory. We now see the thumbnails and videos files we just copied. Let's check the repository status again using Git status. There are no commits yet. To make a commit, we need to add changes to the index. Since we haven't added anything to the index, there's nothing to commit. However, we can see that there are two untracked files. These files are not yet managed by Git. To manage these files with Git, we need to add them to the index using the git add command. Let's run git add thumbnails.html to this file. Checking the status with git status, we see that the thumbnails file is now in the staging area indicated by changes to be committed. The videos file, which we didn't add, remains untracked. Using the git status command with the -s option shows a simplified view of the repository's status. Here, we see that thumbnails is in the index indicated by the question mark symbol meaning untracked files. To check the changes that are currently in the index, you can use the git diff command. By running git diff with the staged option, you can see the changes that have been staged for the next commit. This means that if we create a commit now, these changes will be recorded. Next, let's add the video file that haven't added to the index yet using the git add command. We just added the file. After adding it, we can run the git status -s command to check the current state. This command will show that both files are now added to the index. Run the git diff staged command again to check the changes in the index. This shows the changes to the thumbnails and videos files. Press the Q button to exit and let's commit these changes. We can do this with git commit -m command. Let's put initial commit as the message. Now, we have created the initial commit and we can see that both files are now committed. If you run the git log command, you can check the current commit history. You will see that there's one commit in the history with the commit message initial commit. At this point, let's run the git status command again. This command will show that there's nothing to commit because the changes we made have already been recorded in the commit, meaning there are no uncommitted changes. Finally, let's clear the terminal screen using the clear command to keep our workspace organized. If you run the git log command, you'll see that there's one commit in the history. Now, let's modify a file. Using the ls-al command, we can see that there are currently two files in the directory. We will modify these two files. While we can make these changes directly in the terminal, it is easier to use the program. Let's open Finder and navigate to the repository task directory we created. We will edit the thumbnails file using a code editor. Let's look at the file contents. We will copy a portion and add 4 new lines. After making these changes and saving the file, we will return to the terminal. Running the git status command will show that there are changes in the working directory. These changes haven't been committed yet. By running the git diff command, we can see the changes made in the working directory. The thumbnails file has been modified with 4 new lines added. Let's add these changes to the staging area. While we could specify the file name using a dot allows us to add all changes in the current directory to the index. When we execute this command, it will add the thumbnails file to the staging area. Next, let's run the git status -s command to check the current state. This will show that the thumbnails file have been added to the index indicated by the M for modified. To see the detailed changes that haven't been staged, we can use the git diff stage command. This command shows the modifications that have been staged and will be included in the next commit. Let's create a commit with the message second commit by running the git commit-m second commit command. This will create the commit. Now, if we run the git log command, we will see the commit history. It will show our initial commit, and now it will also show the second commit we just made. This confirms that the commit was successfully created. In this practice, we learned how to create a repository in the terminal and making commits using Git. Let's learn how to create a repository and make commits using Third3. First, open the Third3 app. When you open Third3, you should see a window like this. If this window does not appear, select Show Repository Browser from the menu bar. This will bring up the desired menu. In this menu, there's a new button at the top left. When you click this button, several options for creating a repository will appear. We will proceed with creating a repository locally. From the menu, select Create a Local Repository. When you choose this option, a menu will appear asking you to select the location and name for the repository. You can set the location to your preference. I will adjust the location slightly. Let's create a new repository in a folder named Git Repository Practice. After creating the repository, you will see the newly created repository menu appear in the repository browser. Double-click on this repository. By double-clicking, you can open the newly created repository. Currently, since we have just created the repository and haven't recorded any changes, the history section will be empty and there will be no files added, so the file's status will also be empty. Let's add a file to this empty repository and create a commit. To add a file, open Finder. The Git repository we are using is in the Git Repository Practice directory. You won't see the Git repository here initially, but if you press Shift Command Dot, you can view hidden files and folders. Let's try it. When you press the keys, you will notice the hidden Git folder appears. When you open it, you will see a list of files and folders that are generated by default when you first create the Git repository. The Git directory is a hidden directory. Let's change the settings again so that the hidden directories are not visible. Now, the Git directory will no longer be visible. Let's copy two files into this working directory. Copy the two files to the clipboard, then select Paste to Items to paste the two files here. Now, let's return to Third3. In Third3, when you check the File Status menu, you will see three main areas. The bottom area represents the working directory. This menu shows unstaged files, which are files that have not yet been added to the staging area. The middle area shows staged files, which are files that have been added to the staging area. Lastly, the right area is used to view the contents of the selected file or to stage parts of the file selectively. We added two files to the repository folder, and since these files haven't been recorded yet, you will notice a question mark in front of them. This question mark indicates that the files are untracked by Git. To convert untracked files to tracked files, what should we do? We need to add them to the staging area. Select the two files. To add them to the staging area, you can choose Stage Files from the menu, but you can also simply drag and drop the selected files into the staging area. When you do this, a plus icon will appear. Now, the two files are added to the staging area. You can see that the question mark icon has changed to a plus icon. On the right side, you can view the changes made to the selected files. After adding files to the staging area, you can write a message and commit the changes to the record them. Let's create a commit. Enter the message, initial commit, and click the commit button at the bottom right. Since the commit is made, there are no remaining changes. Now, let's check the commit history. You can see that there's an initial commit in the commit history. For reference, the current branch we are using is the master branch. When a new repository is created, the master branch is automatically generated, so we currently only have the master branch. In the past, the master branch was created as the default branch, but recently, the main branch is often used instead of master. In this way, we have recorded the changes of the two files as a single commit in the repository. Now, let's try modifying a file. Go back to the working directory of the repository in Finder. Let's modify the file named thumbnails among the two files in the working directory. Open the file with a text editor. Add a few lines to the file. After adding 4 lines, save the files. Now, let's return to Thread3. In Thread3, if you look at the commit history, you will see uncommitted changes listed. This indicates that there are changes that haven't been committed yet. At the bottom, you can see the modified files and their contents. To view this in full screen, select the File Status menu from the left sidebar. When you select this menu, it shows the files that haven't been modified in the working directory, and you can see the changes on the right side. If you want to commit the changes, select the file and drag it to the staging area by holding down the left mouse button. To remove the file from the staging area, select the file and drag it back to the working directory area. This will change the file to an unstaged state. If you want to commit only part of the changes made to a file, select the specific changes on the right side. Choose a line and click the Stage Lines button. As a result, you will see the same thumbnails file appear in both the staging area and the unstaged area. 3 lines of changes in the thumbnails file are still unstaged, while only the previously added line is in the staging area. Now, select the 2 remaining lines by holding the Shift key and then click the Stage Lines button. These 2 lines will be added to the staging area as well. Now, we have 3 lines added to the staging area. Let's commit these 3 lines. Enter the message, update thumbnails 1, and perform the commit. The commit has been created. If you check the commit history, you will see the update thumbnails 1 commit listed. The changes that we did not add to the staging area will remain here in the working directory. Let's commit them as well. By doing so, you can create a commit for the one-line change. This is how you create repositories and commits using Thread3. Let's summarize what we have learned in this lecture. The repository structure of Git can be divided into the working directory, the index, and the object database. The working directory is the directory where work is performed. Changes to the content of files occur here, and when a specific commit is checked out, the content here is updated accordingly. The staging area, index, is positioned between the object database and the working directory, providing flexibility to selectively record changes. Blobs are created not at the time of commit, but when changes are added to the index. Trees are created through the index. The object database is where changes are stored. The types of states for files managed by Git include tracked, untracked, modified, unmodified, staged, unstaged. To change the untracked state to tracked, simply add the file to the index. When adding or removing content from a file in the index, it can be done in smaller units than the entire file content. It globally uses a directed acyclic graph (DAG) for data storage purposes. In this lecture, we explored the structure and operation of a Git repository and how file state management is handled in Git. Understanding these concepts will greatly help you in comprehending the topics we will cover in the future. Note that Git objects like blobs and trees mentioned in this lecture will be covered in more detail in another lecture focusing on Git's internal structure, so don't worry if you haven't fully grasped everything yet. Thank you for attending this lecture. See you next time. Goodbye.